there is a material called iridium. You have probably never heard of it, but without it, green hydrogen, one of Europe's biggest bets for industrial decarbonization, cannot be produced at scale. The entire European Union produces 2% of what it needs. This is not an edge case, it is the story of the clean transition in one element. The technologies Europe is building to get off fossil fuels require material that Europe doesn't have, can't easily get, and is only now starting to take seriously. In this video, I'm going to show you what critical raw materials actually are, why they have become a geopolitical flashpoint, and what this means for the careers and competences that organizations will desperately need in the next 5 years. I'm Anastasia, PhD in Sustainable Manufacturing, founder of Green Swan, and a regulatory intelligence specialist for the green transition. I have spent years reading the documents that most professionals have never seen and translating them into what matters for businesses and the people working in them. Critical raw materials are materials that are economically important, have high supply risk, and for which there are limited substitutes. The European Union publishes an official list. It currently includes 34 materials. Names like lithium, cobalt, graphite, gallium, germanium, rare earth elements. You encounter them every day without knowing it, or maybe you know. The permanent magnet in an electric vehicle motor contains neodymium and dysprosium. The solar panel on a roof contains indium and tellurium. The smartphone in your pocket contains gallium, tantalum, and rare earth elements. The wind turbine outside of Norwegian fjord contains praseodymium and terbium. And here's the problem. The green transition and the digital transition both require massive amounts of these materials. Electric vehicles use 6 times more minerals than conventional cars. An offshore wind plant uses 9 times more mineral resources per unit of power than a gas-fired plant. And demand is about to explode at exactly the moment when geopolitical access to supply is becoming more complicated. Let me give you some numbers that explain why this has become a strategic crisis. Lithium, that is the foundation of battery technology. 77% of global supply is extracted in just 2 countries, Australia and Chile. 56% of processing happens in China. Rare earth elements for electric vehicle motors and wind turbines. China dominates both extraction and processing of the key materials, neodymium, dysprosium, praseodymium, and terbium. Gallium, that is used in semiconductors, solar panels, and electronics. China produces over 90% of global supply. In 2023, China introduced export restrictions on gallium and germanium, and in 2025, further restrictions followed on tellurium, tungsten, molybdenum, bismuth, and indium. Iridium and palladium, essential for electrolyzer production for green hydrogen. An electrolyzer requires more than 40 raw materials. Russia and South Africa are major suppliers. The European Union produces almost none. And this is not a technical footnote. This is Europe's most significant strategic vulnerability in the clean transition. So the technologies that are supposed to replace fossil fuel dependency are creating a new dependency on materials controlled by a small number of countries, some of which are actively using that control as a geopolitical tool. Europe's response is the Critical Raw Materials Act. Adopted in 2024, it sets 3 binding targets by 2030. 10% of annual European Union consumption of strategic raw materials to be extracted within the European Union, 40% to be processed within the European Union, and 25% to come from recycling within the European Union. These are not aspirations, they are legally binding benchmarks. And the Act also creates a fast-track approval process for strategic projects, like mines, processing facilities, recycling plants. Projects that can demonstrate they contribute to these targets. And it puts due diligence requirements on sourcing because a significant share of critical raw materials comes from regions with serious human rights and environmental problems, like artisan cobalt mining in the Democratic Republic of Congo, or lithium extraction affecting water supplies in Chile, or rare earth processing with significant environmental damage in China. So the conflict mineral regulations, the European Union battery regulations, and the Corporate Sustainability Due Diligence Directive all add additional layers. third-party audits, public reporting, and supply chain transparency requirements. The message is clear. Europe wants the materials, but it also wants to know where they come from, under what conditions, and at what environmental cost. One of the most important responses to this challenge is circularity, recovering critical raw materials from products that have already been used. The opportunity is real. Solar panels are reaching end of life in growing numbers, from 45,000 tons of waste in 2016 to potentially 8 million tons globally by 2030. Each panel contains silicon, silver, indium, and tellurium, all recoverable if the infrastructure exists. Electric vehicle batteries contain lithium, cobalt, nickel, and manganese. Battery recycling is growing fast, driven directly by the battery regulation. But here is the honest picture. Recycling currently meets only a modest fraction of European Union demand for critical raw materials, and scaling it up is harder than it sounds. Like, some materials exist in such small concentration products that recovering them requires processes that don't yet exist at industrial scale. Neodymium, the rare earth in electric vehicle motors, has no industrial-scale recycling processes in Europe today. Collection and sorting infrastructure is still being built, and the economics only work when the price of the virgin material is high enough to justify the investment in recovery. Recycling is essential, but it's not a short-term solution. It's a decade-long infrastructure project, and the people who can build it don't yet exist in sufficient numbers. There is a tension at the heart of the critical raw material strategies that almost nobody discusses openly. Opening new mines in Europe, which the Critical Raw Materials Act fast-tracks, creates environmental risks. New mining operations affect local ecosystems, water systems, and communities. And some of the deposits Europe wants to open are in or near protected areas. At the same time, if Europe doesn't open those mines, it continues to import from countries where environmental and social standards are much lower. The environmental damage doesn't disappear, it just happens somewhere else, where European regulations don't apply and where European consumers cannot see it. And there is one more layer. Extracting lower-grade mineral deposits, the ones that Europe still has, requires more energy and more processing per unit of material. If that energy comes from fossil fuels, you partially undermine the climate benefit of what you are trying to build. The professionals who can navigate this tension, who understand the trade-off between supply security, environmental impact, and climate targets simultaneously, are the professionals, those people that organizations will need and cannot find. So, what does all of this create in terms of roles and competences? Let me be specific. Critical raw material sourcing specialist, someone who understands which materials are in which products, where they come from, what the supply risk profile is, and how to build a diversified sourcing strategy. This sits inside procurement, but it requires material science knowledge, geopolitical awareness, and regulatory competence that traditional buyers don't have. Second is supply chain due diligence managers for materials. The conflict minerals regulation, the battery regulation, and the corporate sustainability due diligence directive all require companies to verify and document where their materials come from and under what conditions. Someone needs to own that process, building audit frameworks, working with third-party verifiers, and managing supply relationships across multiple tiers. Circular materials engineer. The gap between what materials exist in the end-of-life products and what can actually be recovered economically is a technical problem. Closing it requires engineers who understand both material chemistry and industrial process design. This role is emerging in battery recycling, electronics recovery, and construction materials reuse, and it barely exists as a defined profession today. Urban mining project developer. Identifying, securing, and developing secondary raw material streams from waste electrical equipment, from construction and demolition waste, and from end-of-life vehicles. This combines project development skills with materials knowledge and regulatory understanding of waste classification and end-of-waste criteria. Critical raw materials compliance managers. As the Critical Raw Material Act, better regulation and due diligence requirements all generate reporting and documentation obligations, someone needs to own that compliance function. This is a new position in either the compliance or sustainability team of any company that uses strategic materials at scale. And beneath all of these specific roles, 3 cross-cutting competences that are in short supply everywhere. The first one is material literacy, understanding what is in your products, where it comes from, and what its supply risk profile is. This is entering procurement, product development, legal, and finance simultaneously. Geopolitical risk assessment, the ability to evaluate supply chain exposure to export restrictions, political instability, and concentration risks. This used to be a specialist function in large commodity trading firms. It's now relevant in any company that manufactures physical products. And the third one is circular process knowledge, understanding how materials can be recovered, at what purity, at what cost, and what product design choices make recovery possible or impossible. This sits at the intersection of chemistry, engineering, and business. And people who hold all 3 simultaneously are exceptionally rare. And here's how to use this information as a career signal. Pick any product your company makes or sells and ask 4 questions. What critical raw materials does it contain? You may not know, but someone in your organization needs to. Where do those materials come from? Like which countries, which companies, which regions, and what is the geopolitical risk attached to each? What regulations now apply to sourcing, documentation, and reporting for those materials, like battery regulation, conflict minerals? Which ones touch your supply chain? And what happens to those materials at the end of life? Is there a recovery pathway? Is it your responsibility as a producer? And if your organization cannot answer those 4 questions confidently, that is a competence gap. And a competence gap is a career opportunity. Critical raw materials are not a niche topic for mining engineers as it was before. They are inside every electric vehicle, every wind turbine, every solar panel, every smartphone, every data center, and increasingly inside the regulatory obligations of every company that uses them. The race to secure these materials is already running. The workforce to manage, recover, and account for them is years behind. Pick your industry. Find out which critical materials are in your products or your clients' products. Ask which of the competences I described you already have and which you don't. That gap is your next move.